Hi everyone, today we are going to talk about writing equations of polynomials. And we're going to do this in two parts, so there will be two videos for this. And before we start, it's important to just see what a polynomial graph looks like and just a general description of it. So I have three polynomial graphs here. And you can see what they all have in common is they all kind of look almost like a roller coaster shape, like they go up and down. And really importantly, at all of these turning points where they go up and down and change direction, those turning points are smooth curves. So they're not hard pointed edges. They always are rounded and smooth, okay? The other thing about polynomials is that the ends of the polynomials, we're going to call this the end behavior. There's always arrows on either end. And those arrows are either going upwards towards infinity or they're going downwards towards negative infinity. So they're always going towards infinity or negative infinity. And then lastly, is that polynomials have really important features, which we've actually talked about earlier this unit. And we have a few different names for them. Often they're called zeros. Sometimes they're called x-intercepts or roots, or you may have also referred to them as solutions. And those are really important points on the graph. Those are where the graph touches the x-axis. So I'm just gonna zoom in and point out the roots or the x-intercepts. So where my smooth curve touches the x-axis. So this first graph has 1, 2 zeros or 2 x-intercepts. The second graph, there's 1 here, 1 here, and 1 here. That has 3 x-intercepts. The third graph, there's 1 here, here, and here. That has 3 x-intercepts. All right. So what comes next in our equations of polynomials is the format of a polynomial. And we are going to talk mostly about polynomials in factored form, okay? We've talked about factored form previously when we studied quadratics. Factored form is when our factors are separated by parentheses and they're all multiplied together. So I want to look at this general factored form. I'm going to highlight the factors. The factors, what we call, are what is contained within the parentheses. So there's a factor, here's a factor, here's a factor. And each factor has something in common. They all have an x, right? So x, 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 that never changes. And we are subtracting something from the x. Now, the subtraction symbol is important. The subtraction symbol reminds us that when we input a value into the factor, we always do the opposite. So the minus symbol in this case stands for the opposite. And the z1, z2, z3, that stands for 0, number 1, 0, number 2, 0, number 3. And there's a dot, dot, dot because you might have more than 3 factors. You might have 4 or 5 or 6, etc. It could go on and on. And so we always have the same format where in parentheses we start with the letter x and then we do minus or plus depending on what value our 0 is. The last thing that's really important here is that every polynomial has what we call an a value. And the a value tells us a lot about the graph. It tells us about the end behavior of the graph. And every polynomial has an a value, every one. Sometimes you won't see a number there, but every polynomial has one. So if there isn't an a value there, it means that we assume that the a value is the number 1. Okay, so every polynomial has an a value. So we're going to start to put this together with a multiple choice example. And we're going to compare the graph of a polynomial to a list of equations and figure out which equation must be our polynomial. So let's look at the options first before we jump in. Notice how the options are all in factored form. They all have the same a value. I just want to highlight the a value. Do you see how the a value, it's all in the front? In this last one, careful, the a value doesn't include that x, it's just the number, it's just 1/2. So the a value is the same, which means I don't really have to worry about the a value. I'm just going to look at the factors and see which factors match my graph. So I'm going to go to my graph, and I know that the factors should show us where the zeros are located. So in my first graph, I'm going to look at, there's a 0 here, that's at -3. Here, that's at -2. And here, that's at +1. Now remember, when I write my factored form of my graph, I should do the opposite. So if I have a 0 at -3, I should have a factor of x plus 3. So I'm going to look at my multiple choice. Do you see how this one has x minus 3? That's a trap. That is incorrect. I have another, this one looks good. This one has an x plus 3. This one has an x plus 3. Okay, so let's look at the next factor. So the next 0 is -2. And if the 0 is -2, that means the factor should be +2, x plus 2. So again, we already ruled out that one, A. I see the second one, look how that has an x minus 2. That means that it can't be letter B. I see an x plus 2 and an x plus 2. Okay, let's look at the last factor. That is a 1. It's positive, which means my factor should be x minus 1. And so I see here that I have an x minus 1 and an x minus 1. So there must be something about these two choices that is different. And the big difference is that the last choice, option D, has this extra x here. And that means that there is another x-intercept, or another 0. And we can clearly see that there are only 3 zeros here. So it cannot be option D. It has to be option C. It only has 3 factors to match my 3 zeros. All right, let's look at example 2. So for example 2, you might want to pause the video and just give this a shot and see if you want to try it on your own. If not, I'm just going to go over it. So again, for example 2, I'm just going to quickly look at the a value. And the a value is kind of tricky this time. The a value, actually, there isn't a number, but there's a negative symbol. That means that the a value is -1. We don't write the number 1, we just write the negative symbol. So the a value is the same for all of these. So I don't have to worry about that. Next, I'm going to look at the zeros. So let's zoom in a little bit. I have a 0 here at -3. I have a 0 right here. That's at 0. And I have a 0 right here at 1. Okay, so let's think about what we did last time. If I have a 0 at -3, that means my factor should be x plus 3. I'm just going to go to the next one. If I have a 0 at 0, it means my factor should be at like x, and it actually doesn't matter if I do plus or minus, so I'll do minus 0. But x minus 0 in math language, that's kind of like extra. We don't need to write -0, it doesn't change anything. That just means x. It just means if you have a 0 at 0, it means that one of your factors should just be the letter x. That's the same as saying x minus 0, just x. And then my last 0 is 1. That means that I should have a factor of x minus 1, because 1 is positive. So let's see. So I should have an x plus 3. So here's my x plus 3, so I know it can't be A or B. I need to have an x minus 1. These both have x minus 1s. The way to find our answer here is this last 0. Remember, we have an x-intercept at 0. That means the factor is x minus 0. which is just x. So I need to have this x all by itself out front. So letter C actually only has 2 zeros, whereas letter D has 1, 2, 3 factors means 3 zeros. All right, now we're going to put everything together and actually write the equation of a polynomial given its graph. So I have 4 steps here to do this. So we're just going to walk through the steps with an example. And so the first step says to use the x-intercepts to write the factored form of the equation. And it says to leave the a value. So I'm just going to remember, this is our factored form. So f of x equals a, x minus z, and then we have x minus z again. Or you could put like z2, dot, 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 right? So we're going to use that format. So I'm going to use the x-intercepts to write the factored form of the equation. I'm going to leave the a value in my equation. So this is step 1. So I'm going to write f of x equals, I'm going to leave my a value alone. And if I look at my graph, I have an x-intercept of 2 and an x-intercept of 8. So I need 2 factors, x minus 2 and x minus 8, because I took positive 2 and positive 8 and made them opposites. So that's the end of step 1. We've finished step 1. Step 2 says identify another point. So it can't be the 2 points I just picked. It has to be a different point. Identify another point other than the x-intercept and plug in this point for x and y. So every graph you look at is always going to give you a point. If I zoom in, a lot of times, it's hard to see in this case, but I can see there is supposed to be a point marked right there. And that is the point 0, 12. That is actually the y-intercept. It's where my graph crosses the y-axis. So I'm going to take that point 0, 12. 0 is my x-coordinate, 12 is my y-coordinate, and I'm going to replace x and y in my equation with 0 and 12. One thing to remember, f of x is just a fancy way of writing y, okay? So remember that f of x is the same as y. So I'm going to replace f of x with 12, my y-coordinate. I'm going to replace x with 0. 0 minus 2, I have to replace it twice. 0 minus 8. That is step 2. I finished it. Step 3 says solve your equation for a to determine the a value. So if you look at this equation, I have to try to figure out what a is. So I'm going to solve my equation for a. So I get 12 equals a. 0 minus 2 is negative 2. 0 minus 8 is negative 8. And I get 12 equals, and I'm going to do something here to make this a little bit easier. 2 times negative 8 is positive 16. So I'm going to write this as 16a. Rather than a times 16, I'm just writing it as 16a. And we're going to solve this equation for a. So to solve this equation for a, to isolate a, divide by 16. That will cancel my 16. And I get a equals 12 over 16. I'm going to reduce that fraction by dividing the top and the bottom by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. And I get a equals 3/4. It's also perfectly okay if you want to convert 3/4 to a decimal. If you prefer to work with decimals, that's okay. Delta Math accepts decimals as well. All right, so a is 3/4, or you could write it as 0.75. Our final step, that was step 3, is to write your final answer. So rewrite our original equation, but replace the a value with the number we just found. So our final answer is f of x equals, my a value is 3/4. X minus 2, x minus 8. That is my final answer. That is the equation that describes the graph you are looking at. F of x equals 3/4 x minus 2, x minus 8. We're going to do one more example together, and then you can try example 3 on your own. So here's another example. All right, so we are going to set up our equation first. I'm going to set up my equation, f of x equals a. And let's look at my zeros. So this is -3. This is 0. And this is, actually, yeah, is that 3? 3. It's hard to see because I don't have my grid labeled. All right, so I have zeros at -3, 0, and 3. And actually, before I have to erase something really quick because A, the first thing I notice is I have a 0 at 0. Remember, that means that my factor is x minus 0. And an easier way to write that is just x. So one of my factors is x, just x. One of my factors is x plus 3. That's the opposite of minus 3. My last factor is x minus 3. That's the opposite of plus 3. All right, so I have wrote my general equation. I've left a in my equation. The next thing that I do is pick any other point and plug that point in for x and y. And there will always be a point indicated for you. So here's our point, right? And 2 is my x, -20 is my y. Remember that f of x is the same as y. So -20 equals a. I'm going to put in parentheses here, I'm going to plug in just 2 for x, and then 2 plus 3, and then 2 minus 3. So I had to plug in x 3 times there. So let's solve this equation. -20 equals a, 2 multiplied by 2 plus 3, that's 5, multiplied by 2 minus 3, which is -1. So I get -20 equals a, and 2 times 5 is 10, times -1 is -10. I'm actually going to erase my a and write it this way, -10a, right? And then to solve, I divide by -10, and I get a equals -20 divided by -10 is 2. Don't forget to write your final answer. And the last thing that we do is write our final answer. So our final answer is our equation, but I'm just going to replace a with the value that I just found, right? So f of x equals 2x, x plus 3, x minus 3. And there's my final answer. All right, so the last example is for you to try on your own. I'll put it up here. Let's try this one on your own, and good luck.